This is the grade 10 science chemistry unit, balancing equations practice sheet. Atoms are not created or destroyed during a chemical reaction. You'll remember that we learned this in the notes regarding the law of conservation of mass. Mass is neither created nor destroyed. Therefore, we have the same amount of mass on one side that we have on the other side of an equation. Scientists know that there must be the same number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients in front of the chemical formula in the equation. You cannot add or change subscripts. Okay, and so at the front here, this one I've designed it so that you can see that this is where you would put the coefficient within the box. Okay? It's not always going to have a box, but in this case, it does. The little numbers are the ones like oxygen has here, okay? And oxygen has a 2, so that means there's 2 oxygens. Also, remember that if there's nothing here beside, if there's no subscript beside a chemical or beside an element, that we assume there is a 1. Okay? Whenever something is blank, we assume it is a 1. And you cannot change these. Okay? You cannot change the subscripts, you can only change the coefficients. And so if you follow these steps that I've provided for you, you should be able to balance chemical equations. Step 1, determine the number of atoms for each element. Now, on this particular question, I've set it up so that you don't even need to identify them. I've identified them for you. On your own, you'll notice in the next part of the practice section that you do have to write them down yourself. It's provided for you here, but it's not provided for you there. So you're good. For example, you'd have to write down Na, Mg, and F on this side, and Ng, or Na, Mg, and F on this side. And I always recommend having whatever the element is the same across. They won't be in the same order on both sides of the equation because they're going to be switching around. But you will find it much easier when it comes to balancing if they are that way. And I've provided it that way up here. Okay. And so let's go through the steps. So the first thing is to determine the number of atoms for each element. Well, for magnesium, there is how many? You'll notice that throughout this tutorial or information session that I'll give you opportunities to pause the video. Take the opportunity to pause the video kind of to test yourself as you're going through. So I would pause it now. And I want you to write down here how many magnesiums there are, and then you'll unpause it after, okay? So go ahead and do that. Okay, so you should notice that there is 1, right? Because there's no coefficient listed there. We know it's a 1. Okay, now oxygen. How many oxygens are there? Go ahead and pause the video. 2. That's right. There's 2. Okay, oxygen has 2. What about the magnesium and the oxygen on this side? Let's write down the magnesium. Go ahead and pause. It's 1, right? Okay, and on this side, for 1, yep, that's correct. And so we start with this, okay? Now you can see that magnesium is balanced, but oxygen is not. So what we do is we pick an element that is not equal on both sides. Okay, that's the next step. And so we notice that these guys are equal, but these guys are not. How would we make this O, which is this one, the same as this one? Remember, we can only multiply it by a coefficient. And so we put a number up here. I want you to write down what number you think, and it's good to use a pencil, by the way, so you can erase this if you make mistakes. And it is okay to make mistakes. Okay, so put in the number. Remember that you're multiplying this number by the number, each number in here. okay? Whatever I put here affects this compound. Whatever I put here affects this element. Whatever I put here affects this element, okay? So this one right here, pause, that's right, okay? If you wrote a 2, you're correct, right? So what happens here is this 2 is multiplied by 1. 2 times, so 1, the 1 that was there times 2 is now equal to 2, right? Now down here, we have the 1, or the 2 times the 2 as well, and that is equal to 2. So now we have another predicament. This one is 2. This one is 2. These are both balanced. But this one is not anymore, right? Because now this magnesium, we've had to change it. It's now a 2. And this magnesium is now a 1. So what do we do? Well, we multiply this one. If we were going to make this the same as this, what would we multiply 1 by? Pause. Okay, write down your answer. Right, we'd multiply it by 2. So if we put a 2 here in front of the magnesium, we now have a balanced equation. Magnesium and magnesium, 2 and 2. Oxygen and oxygen, 2 and 2. And so now this is what we would call a balanced equation. Okay? Oh, I guess I didn't talk about these as I went through, but hopefully you were able to get it as I went. I added a coefficient, I'll talk about it now. I added a coefficient in front of the formula with the element to adjust its count, okay? So that's what we did here is we added that coefficient. Then we continued adding coefficients to get the same number of atoms on each element on each side. And so that's essentially what we did here, right? We balanced the equation. Hopefully that was helpful, and I'll do a few more of these.